All right, so you were trying to find the average velocity, and kind of the reason we did these two questions together is finding instantaneous velocity and average velocity kind of have two different ways to do those because they're different things. So instantaneous velocity, I want a velocity function so that I can apply that specific time and find it at a very specific point. Average velocity has a different equation. So V average is my displacement divided by my time. So I need to find my final position minus my initial position divided by my final time minus my initial time. So in order to find average velocity, I'm going to need a position function. So what you should have done here, V average, is you needed to find the position at 8 seconds minus the position at 0 seconds, all divided by the 8 seconds minus the 0 seconds. Now, some of you might have gotten to the point where you've used the average equation in calculus, and we could say that, oh, this is just the average of our position function. And so you could use that as well, where you take the integral from 0 to 8 seconds divided by that interval. That works too. Go ahead, plug that in here, and you should get 104.16 minus the 28, which was our initial, divided by our 8 minus 0. And again, same thing over here. If we get a positive value, which we will, that will mean east. We get a positive 9.52 meters per second. The fact that it's positive tells me that it's east. And so my average velocity will be 9.52 meters per second east. So again, doing instantaneous and average velocity, even though they sound like they're the same thing because they're both velocities, they have two different processes for finding the instantaneous velocity versus the average velocity. And they won't always be the same, especially if you have a situation where that velocity is not constant.